Subterranean termites, Macrotermes gilvus, or more commonly known as soil termite, is a common mound-building termite that attack crops and wood products. Subterranean termites occur commonly in tropical soils, especially in the rainforest, where they play an important part in recycling wood debris and decaying plant materials. Macrotermes gilvus represents a serious pest of wooden structures in the Philippines, especially in suburban and rural areas. It is also common and causes major problems in other tropical countries such as Malaysia, Indonesia, Thailand, and Vietnam. The economic impact of termites may exceed $11 billion each year in the United States and $14 billion worldwide. The majority of damages to homes and other structures is caused by subterranean termite species in the family Rhinotermitidae. Subterranean termites are the most widespread destructive termite group in the Philippines. They attack wood buried in or indirect contact with the ground. Termites become economic pests when their appetite for wood extends to human homes and timber structures. The attack results in significant structural damages, leading to early replacement and reduction of service life of wooden structures. No data on total financial losses due to termite attack in the Philippines is available, but an estimate of the monetary value due to destruction to human property and agricultural or forestry crops is about 8 to 10 million US dollars annually. The standard method of controlling subterranean termites in the Philippines is to apply liquid termiticides to soil between the wood structure and the termite colonies on the ground. It is referred as soil poisoning. The treatments for the subterranean and dry wood termites result in varying degrees of success, depends on the skill of the applicators, type of treatment, the dosage, and the degree of infestation. Chlordene, an effective termicidal, and other chemicals were banned in most places in the world due to its high toxicity, persistence in the environment, and the ability to bioaccumulate in the food chain.
The crude leaf extract of Atis was used to combat the termite, which has a number of insecticidal characteristics in various studies across the world. Recently, a phytochemical analysis in the laboratory of Department of Science and Technology was conducted, and it was proven that the leaves contain anthraquinones, which is a derivative of anthracene that can be used as an insecticide. This test proves that the Atis leaves extract contain an insecticidal property. The study aims to lessen the use of chemical termiticide and to test the termiticidal activity and repellence rate of the ethanolic Atis leaf extract as a substitute for termiticides and termite repellent. And that is why the researchers came up with a study entitled The Effect of Atis, Annona squamosa, leaf crude extract on the mortality and repellence of the subterranean termite, Macrotermes gilvus.
For the collection of materials, the Atis leaves were collected from the researcher's house at NHA Bangkal, Davao City. The leaves were washed to guarantee the characteristics and the effectiveness will not be affected. The ethanol used in the study was bought in the GSIS subdivision, Davao City. For the preparation of the extract, the collected Atis leaves were air-dried for days and weighed after it was air-dried. Then it was chopped using a clean pair of scissors and placed in a clean container to avoid contamination. The chopped air-dried leaves were added to 1,000 milliliters of 95% ethanol, and the leaves were soaked for 3 days. After 3 days of soaking, the extract was filtered using clean cloth to strain the leaves from the ethanol mixture, and the filtered extract was moved in another container. It was then brought to the Department of Science and Technology for Rotary Evaporation. For the dilution of the extract, the crude extract was then diluted using a 1,000 milliliter of distilled water. For the first concentration, 5 ml of crude extract and 95 ml of distilled water was added in the graduated cylinder. For the second concentration, 10 ml of crude extract and 90 ml of distilled water was added in the graduated cylinder. The dilution of the extract was conducted under the guidance of our research mentor. For the preparation of the termites were collected in Shrine Hills, Davao City. The termites were then brought to the researcher's house at Teka Homes, Tapunan, Davao City. They were given days to adjust to their new environment and also to avoid stressing the termites. For the termiticidal test, 10 termites were placed in a clean glass, and this test had 5 replications. Each group were sprayed with the 4 treatments, the 5% concentration, the 10% concentration of the extract, and the distilled water for the negative control and the solignum for the positive control. After spraying, it was monitored for 24 hours with an interval of 1 hour to check the mortality. For the repellents, the termites were placed in a clean plastic storage. 5 termites were placed in plastic storages containing a 2 by 1.5 inch woodblock. The 20 plastic storages were divided into 4 groups since there are 4 treatments. Each group got their wood blocks brushed by their corresponding treatment. It was monitored for 24 hours with an interval of 1 hour to check the repellency. For the data collection and analysis, the data collected from the conducted experimentation was analyzed in an open source statistics program, Jeffrey's Amazing Statistics Program or JASP. The statistical tool used for the data analysis is ANOVA, and the test used to evaluate the differences is the post-hoc test. For the results of the termiticidal test, the data in Table 1 shows the mortality of the termites on the two concentration of Atis extract, which is 5% and 10% concentrations. In Table 1, the average mortality rate of 5% crude extract is 9.4. Meanwhile, the 10% crude extract had a mortality rate of 9.6, which is higher than the 5% concentration. The results shows that the mortality rate of the 5% and 10% crude extract concentration has a mortality rate of 8 or higher out of 10. In the post-hoc comparison, which can be seen in Table 2, there are three significant groups in which the two crude extracts were involved. Based on the results, the two concentrations of Atis crude extract are considered as significant groups. For the repellancy test, the average repellence of the 5% concentration is 2, which means that 2 out of 5 termites repelled with the use of 5% concentration. In the 10% concentration, the average repellence is 2.4, which also means that only 2.4 of the termites repelled using the 10% concentration. The result shows that the 5% and 10% concentration can only repel 2.2 termites for the first 4 to 5 hours.
And now, let's move on to the discussion of the results. The Atis leaves caused mortality and repellency to the termites maybe because of the phytochemicals that are present in the leaves. The leaves consist of various chemicals. The chemicals that are present contain alkaloids, carbohydrates, fixed oils, tannins, and phenolic compounds. Earlier works in the phytochemistry of Atis leaves reported the presence of alkaloids, flavonoids, phenols, saponins, glycosides, and etc. in water, methanol, chloroform, and petroleum ether extracts. Some studies also show the chemicals that are present in the Atis leaves. According to Guru Subramanian, there are also chemicals that are present in the leaves of Annona squamosa, such as lanolin and annonine, which have insecticidal properties that could potentially affect the mortality rate of the termites. Also, according to Patel and Kumar, the leaves contain benzene, annonine, benzyl tetrahydroisoquinone, borneol, camphene, camphor, car-3-in, carbone, carpheline, eugenol, farnesol, geraniol, hexatriaconthane, hexacontanol, higamamine, isocoridine, limonene, linalool acetate, menthone, methylancrinolate, and many more. The presence of eugenol also has a significant effects that cause the mortality and repellency rate. According to Indrayani et al., the presence of eugenol compounds has a potential response for termite control because of its toxicity. It was found out that the toxicity effects of crude extracts depend on the synergic interaction of comprising active ingredients. It indicates that the eugenol present in plant crude extracts may be either toxic or attractive to termites, depending on its concentration, especially the plant species. The following chemicals that are present have the ability to affect the mortality of the termites, but one of the chemicals, eugenol, can be toxic depending on its level of concentration. Farnesol also is a chemical that is in the Atis leaves. There appears to be no disclosure that the farnesol type compounds would be an effective repellent for ants, wasps, and termites, or that when combined with compatible matrix. These compounds would provide for prolonged repellency to ants, wasps, and termites. Geraniol is also present in Atis leaves and also a naturally occurring essential oil. Geraniol is primarily used as mosquito and tick repellent in skin, clothing, and others. Geraniol can also be used for termite repellency. Based on study results, it is shown that Annona squamosa crude extract could have a potential termiticidal effects on subterranean termites. In the quantitative results, it shows that both 5 and 10% concentrations could have a very high mortality averaging into 9.4 and 9.6. It could be a potential for fighting off termite infestations because of the effect of the mortality rate of the termites. On the other hand, the repellence test shows only a small potential since the 5 and 10% extracts could only deter the termites for an average of 4 to 5 average hours. Overall, the crude extract can be a potential termiticide for the subterranean termites but not for termite repellency on the wound blocks. And for the recommendations, add more application in each treatment to gain greater validity of the findings. Try higher concentration levels of the crude extract or the experiment. Also, use different kind of wood blocks to test if the different kind of wood blocks affects the repellency of the leaf extract.